Okay, so now we have a particle moving around a parabola in the first quadrant with a constant speed of increase of speed of 2 meters per second on the x-axis. So what we're going to do, we're going to draw a picture real quick. We have the parabola is right here. It's the regular x squared parabola. And then our particle, we have moving along this parabola it's going this way. It's moving in the horizontal direction we'll just put a little arrow down here, 2 meters per second. So at this time right here, I'm going to form a right triangle here. We have a line that's, according to the problem, we have a line joining the particle from the origin to the particle, and we want to know what this angle here is doing at a specific time. So this far away we have x. This far up we have y, but y we know is x squared, so I'm going to put x squared there. And we got to figure out a relationship between x squared and x. Well, that's opposite side, that's adjacent side, so I'm going to use tangent this time. Tangent theta equals opposite, which is x squared, over x, which we know reduces to x. If we want to find the rate of change of this, we need a derivative. So derivative of tangent, we learned back in chapter 3, is secant squared. And then the derivative of the inside of the function tangent of theta is d theta dt, which is what we're looking for. Derivative of x with respect to time is just dx dt, so that's nice and easy. We need to know what dx dt is. We need to know what theta is in order to find this specific d theta dt. We know what dx dt is because it tells us in the problem. It's 2 meters per second. So I'm going to plug that in. D theta dt. Go back to our original formula here, and we're going to plug in some information. We know that at this particular point, we have let's see here. Tangent of theta is equal to x. Well, they tell us what x should be in our problem. So when does the tangent of theta equal 1 in the first quadrant? Nice and easy. We know that one. That's when theta is 45 degrees, or you can use radians as pi over 4. So if I do secant squared of 45 degrees or pi over 4, depending on which mode you're in, secant is 1 over the cosine. So we have 1 over the square root of 2, 1 over the square root of 2. So if we do the reciprocal of 1 over the square root of 2, we get regular square root of 2. We square root of 2, and secant square root of 45 is just 2. So the answer that we're looking for is the angle is changing at 1 degree per second.